welcome to the first edition of RISC OS Direct, a brand new informative and instructional video series all about the versatile and user-friendly RISC OS operating system, brought to you by the Wi-Fi Sheep YouTube Tech channel and RISC OS Development Limited. Over the course of this series, we'll show you how to get started with RISC OS, the many fantastic software, applications and games for the platform, and even how to program and create your own software and apps. For the purposes of this series, we'll assume you're already familiar with using computer operating systems, such as Windows, macOS, or one of the many Linux distributions, and that you're aware or even own a Raspberry Pi single board computer, even if you've never used one. What many people don't realise is where RISC OS came from and how established it really is. RISC OS started life as Acorn Computer's first commercial graphical user interface, or GUI. The first versions were built on top of the already established BBC Micro platform and were created for the then new Acorn RISC Machine CPU, known today as the ARM processor. From 1987, the first version of RISC OS, codenamed Arthur, was released as the official operating system for the new Acorn Archimedes range of computers. RISC OS continued to be Acorn's main operating system until 1998, when the company collapsed. However, RISC OS lived on and has since been supported and modernised by a number of Acorn clone manufacturers, with products such as the Ionix and later ARMX6 range from Arcomp. In late 2018, the full rights to RISC OS were acquired by RISC OS Development Limited, whom released the OS as fully open source for the very first time. Today, RISC OS enjoys support on a wide range of hardware platforms, including the Raspberry Pi. And it's this low-cost ARM-based single-board computer that we'll be using for the majority of this video series. Getting started with RISC OS couldn't be easier. Before we start, you'll need to choose which Raspberry Pi model to use. Most Pi boards, ranging from the original Model A and B from 2012 through to 2018's Pi 3A Plus or B Plus, will work fine. In fact, you'll notice RISC OS runs fast and efficiently even on the oldest Raspberry Pi board. The Raspberry Pi stores all its information, including its operating system, on an SD or micro SD card, with most Raspberry Pis only supporting the micro SD format. For this demonstration, we'll use this 16GB micro SD card. First, we need to use a Mac or PC computer connected to the internet. Using a web browser of your choice, visit www.riscosdev.com, and from the Downloads tab, click to download RISC OS for the Raspberry Pi. The downloaded .img image file needs to be flashed to the SD card. To do this, we strongly recommend using Etcher, which is available for Mac, PC and x86 Linux systems. Download this software from www.balena.io/Etcher. Once installed and running, select the downloaded RISC OS img file. Next, insert your SD or micro SD card into your computer. If you don't have a SD media drive in your computer, use a USB adapter. These can be purchased online for relatively little expense. In Etcher, select the SD card and finally click Flash. It should be noted that any data on the SD card will be wiped during this process. Once the SD card has been successfully flashed with RISC OS, it needs to be safely removed from your computer. Let's turn our attention to the Raspberry Pi. First, we'll add the newly flashed RISC OS SD card to the underside of the Pi. Next, we'll add a standard USB keyboard and mouse. These plug into the Pi's USB sockets. Any USB keyboard will do. However, we don't recommend using Apple USB keyboards, as a lot of these have built-in USB hubs that tend to draw too much power, causing system lock-ups and stability issues for the Pi. On the subject of USB mice, RISC OS is still designed to use the original 3-button mouse as seen with the Archimedes line of computers. The middle button acting as the same as a right click on a modern PC. Today, most USB mice have a centre clickable scroll wheel. This wheel can be pressed or clicked and will act as a centre mouse button. As with keyboards, we don't recommend using older Apple USB mice, as most of these were one button only, which will work but will cause user operational issues. Most Raspberry Pis have a standard HDMI video out port. A normal HDMI cable can be used to connect the Pi to a modern TV. For older TVs or monitors, most Pis also come with a 3-way AV jack, which, with an adapter, will allow for composite analog video. However, this will only be in standard definition with a maximum resolution of 576i if using PAL video encoding. For users wanting to use older PC VGA monitors, HDMI to VGA adapters can be bought at relatively low cost and most work fine with the Pi. For our setup, we're going to use a flat screen TV with standard HDMI video. Modern RISC OS is capable of going online and networking. However, it will require a hardwired CAT or Ethernet connection, as RISC OS is unable to support Wi-Fi at this current time. A simple and inexpensive patch cable can be used to plug the Pi into a network hub, or, if at home, most broadband routers have spare Ethernet sockets on the rear for use with cabled devices. Finally, our setup will require some power. We strongly recommend using a suitable micro USB 5V mains PSU with a minimal output of 2 amps. There is no power on-off switch with a stock Raspberry Pi, so make sure the main socket power is off or leave the PSU unplugged until required. We're now ready to power on for the first time. First, plug in and turn on your TV or monitor, setting it to the appropriate input, such as HDMI. Now we can power up the Raspberry Pi board. If everything has been followed correctly, you should see the RISC OS boot prompt appear on screen. Whilst booting, RISC OS will try to find an internet connection. This may take a few moments. We're now presented with the RISC OS desktop. RISC OS's desktop environment works in a very similar way to that of Windows, Mac OS or even the many Linux GUI front ends. It's mainly divided into 2 areas: the larger desktop space, known as the pinboard, and the smaller icon bar, which stays fixed to the lower half of the screen in much the same way as the taskbar on Windows or the dock on Mac OS, although it functions slightly differently. On the official Raspberry Pi RISC OS build, you will notice a row of icons placed on the pinboard. These are shortcuts or aliases for a number of key apps preloaded for you onto the system. Left double clicking on any of these will open the corresponding app in much the same way as it would on a PC or Mac. The icon bar has a number of icons on it as well. To the left hand side, you will see an icon for an SD card. On the Raspberry Pi version, this acts as your main boot drive or hard disk. Left clicking it once will open a window containing all your system's contents, including files, folders, and even other apps. To the right side of the icon bar, you'll see a Raspberry or cog icon. On older RISC OS systems, this was an acorn logo. Middle clicking this icon will bring up a sub-menu with the option to shut down your computer. When you wish to finish your RISC OS session, left click this menu option. RISC OS will then display a dialog telling you it's now safe to power off your system. At this point, you can turn off the power to your Raspberry Pi or, if required, click Restart to reset and boot RISC OS again. In all, we feel you'll find RISC OS Direct fast and intuitive to use. Next time we'll look at setting up your system and some of the core apps included and how to make use of them. In the meantime, feel free to look around your new RISC OS system and don't be scared to go ahead and try out some of the software that's included. For more information about RISC OS, please visit www.riscosdev.com. And if you're watching this presentation on the youtube.com/Wi-Fi Sheep channel, then please don't forget to like and subscribe. There's much more to come in this series.